all of you are here for that. And hopefully we don't get noise from next door at the VHF-FM Society meeting. They're expecting trouble.
That won't be noise, that'll be a lot of screaming.
That'll be screaming, and if you know, if you hear gunshots, drop to the floor, okay? All right, what is HSMM? I had somebody ask me that just a minute ago. It's high-speed multimedia. HSMM is a generic term. They used it, I think it's originally from 2003. The ARL coined it. It's a general term. It's not a specific mode. It's digital radio, but not just keyboard communications, as a lot of people think about. It supports all modes, like voice, radio, we do keyboard communication if you want, and file transfers, email, and we can hook to the internet and surf the internet if you so desire. As a result, we need wide bandwidth, and that means high frequencies. So for the purpose of this thing, we're not going to talk about generic HSMM anymore. We're going to talk about a subset, which is called HSMM Mesh. And what we're doing is we're modifying Wi-Fi equipment in general on the 2.4 gigahertz band. And the software is called HSMM Mesh. It is trademarked, and the reason we've trademarked it is so that HSMM Mesh talks to HSMM Mesh. And so that somebody else can't put something else and call it Mesh, HSMM Mesh, and it won't talk to us. That's the only reason we've done it. We use it for all kinds of things, like in shelter operations. We can use it for client email or telephone, written text to hospitals and pharmacies. A lot of times when you're doing a shelter, you've got people coming in from all over the place, and they didn't have time to grab all their medicines. Well, yeah, we can communicate that by voice, but when you get really, really long medical names or medicine names, it's a lot better to have it written down and sending it like a text message or an email. For disasters, we have the bandwidth. We can do real-time video, for example, what we're looking at is putting video up on some water towers and be able to have real-time video of a wall cloud or a tornado or possibly even a fire. We've used it for mesh. Yes, Art. Yes. Yes, you need a video camera up on there. But it's a good way to get the data back down from up to high locations. Photographs, trees down, hail, power lines. For the Richardson Wild Ride, that's what we did. We sent pictures, and we sent them from way out, and we sent them back to the start line so they could show them on the big screens at the start and finish line to show people what was happening out at the different rest stops out in the area. Telephone and telephone video conferencing. When there's infrastructure failure, we can support police, fire, hospitals. It's one of the first applications that they did down in Austin, and that's where they started. They started with Packet, but Packet, with the number of hospitals they had, Packet was just too slow. And so they started expanding it and getting the speed up using Mesh. And now they just use the hospitals for the surrounding counties being able to talk in, and they're trying to expand that out beyond the county that Austin is in. And then supporting responders in the field, ARES, CERT, MRC, the Rapid Response Task Force, which is a section group, and now it's called the Rapid Deploy Communication Assistance Group. They just changed the acronym, so I had to sit down and think about it. But we used the mesh, and what we had was in an area we had a number of stations. We had to separate our HF antennas and everything, and so we had different tents. But we used mesh and a chat function to be able to communicate locally between far apart to shout. And the other nice thing was, because it was typed in, if you missed it, because you were talking or something, you could just see it there, you know, when you got a chance to see what was going on. And public and service events, field day. Here's an example of a Plano Balloon Festival site. And every year we set up a mesh network there. We have, nope, not too far. We have what we call field operations. They keep track of all of the balloons that launch and off the field. And that's what we call field operations. So we have people on the field, but these guys need to have internet access and be able to communicate to the off-field people that are going to be recovering the balloon. We have an accounting trailer that has asked us, you know, we need internet access, so we support them with a mesh node. The flight director, they tell everybody basically go, no go on a flight. And so they need up-to-date weather information, and so they get radar and stuff through our mesh. Last year we had a special event station for our club. That was for the Balloon Festival, and they also had access to the internet through our mesh. And we got internet access from a node that we put on the roof of the First United Methodist Church, and we had to relay at the church because they had a metal roof, so our signal wouldn't go through the roof from their system. So we had to do a couple relays actually at the church site to get it going. For the Wild Ride, the Richardson Wild Ride, this is one of the longest ones that we normally do. W5LT has a little tower here, a 70-foot tower up here in St. Paul. This is Lake Lavon, so this is just east of us here, almost due east. And we put a 19 dB antenna up here on his tower in the horizontal polarity, and we were able to reach these guys, which is Rest Stop 2, and that was about 4.5 miles. And then the other one was Rest Stop 3, which is almost 10 miles up here. And of course, this is all line of sight. This is at 2.4 gig. Yep. And the main thing that you need to know about this is fast. I mean, if you look at, I like to put everything in the same units because then it makes more sense. If you're looking at us, we're looking at 10 to 54 megabits per second. Packet radio, 0.0012 megabits per second. Pactor, which is the fast HF rate, 0.003 megabits per second. D-Star, the high-speed 1.2 gigahertz D-Star is 0.128 megabits per second. These are all raw rates as opposed to what your throughput actually is. This is what I'm trying to keep apples to apples on this thing. Just compared to your home service, FiOS is 2 to 15 megabits up, 50 to 25 down. No, we're up at this rate. T1s, which was everybody was saying was, oh man, if you had a T1, you're set. Well, that's 1.5. And then DSL, you can get it up to 1.5 megabits up, 6 megabits down. Often you get partials, which are like 0.768, 0.512, 0.368. So compare all these numbers to what we're seeing up there. Oh yeah, and then there's always dial-up. For some of you that remember what that is. So if you're going to do this and you're going to use the strategy and you're planning First thing you need to know is what can it do and what are its limits. First off, channels 1 and 6 and 11 are non-overlapping. 2 overlaps with 1 and 6, 3 overlaps with 1 and 6, 4. They overlap each other, and so really there's only 3 channels that are non-overlapping. Channels 1 through 6 are in the ham band. Channels 7 through 11 are not in the ham band. So if we're going to modify these to be in the ham radio, we are going to be limited to channels 1 through 6. The next thing you have to know is 2.4 gigahertz, you really need clear line of sight. Trees attenuate it a lot, hills and buildings, they block it.
People tend to watch the signal quite a bit too.
Yes, it's actually, I think 2.4 is really close to what the vibration frequency of water molecules. So anything with a lot of moisture in it is going to suck up this energy. Pardon? Just a little bit, yes. But you need to, like I said, you need clear line of sight. It actually, I have not had too much problems with rain, but fog would kill us. I mean,
Been there, blocked that.
we've been there, I've worked in light rain and didn't notice much of a problem, but then one day we had a foggy haze and I couldn't get anything. So, this is always a big issue with everybody, is security. The big deal is that, we can't encrypt for the purposes of obscuring our message. But we can encrypt to protect our networks from port 15 intrusions. So what we're doing is we're authenticating and protecting, not obscuring. It's a legal definition, it's a legal difference, but it allows us to use the standard encryptions that are available to Part 15 devices. So we can do this under the following 4 conditions. First off, we have to use it only on frequencies above 50 megahertz. We cannot do any foreign traffic. It has to be a standard and published encryption. And you need to put your encryption key in your logbook. Now, right now, we don't have any of our meshes encrypted. But if we did, we would follow these rules. And if you need more detail, the ARL VHF Digital Handbook, Chapter 7 on HSMM Radio has more details. Okay, how does this work? Well, it basically, the algorithms in here automatically find the shortest route. So if you are over here and you need to get to the internet, it's going to go 1, 2, 3, or 1, 2. And it's going to say, I'm going to go that way to the internet. It's always find the shortest route by number of hops. If somebody disappears, like say this one goes away, it will automatically say, okay, 1, 2, 3, or 1, 2, 3, 4. I'm going to take this one. So it automatically finds the routes, which means it fixes the broken routes. Yes? We're all, everybody's operating on the same frequency. In general, we like to use channel 1, because most of them default the routers, the home routers to channel 6. So we're not going to be where everybody else, or we prefer not to be where everybody else is. And the other nice thing about this is if a new router shows up, it's automatically put into the net. You don't have to sit there and configure and do anything like that. right, so what's needed? Custom software, off-the-shelf Wi-Fi routers, and usually, we're talking 50 to 100 bucks. If you find them used, like I found one out in the flea market today for $15. I picked one up, I used one. I saw a number of them out there for 20, and I was looking for the deals. So I may go back to them towards the end of the day and see if they'll drop the prices. But basically, less than any hammer you could buy. Well, except for the O'Shangs and the Bowfangs. Yeah, they're starting to get down in our price range. You need one that supports external antennas and operates, and you need to operate it in channels 1 through 6 for the ham bands. High gain antennas, you can get those $20 to $100 or more. You can get omnis or you can get directionals. And of course, like with anything else, with an amateur radio, power, batteries, cables, masts, boxes, all the other accessories, but they can be shared with your other bands. Yes?
What kind of cable do you use on the router?
I'll get to that in just a minute. Okay? The custom software is free, and I'll show you where to download that. When you've got your software loaded, it's going to look like this, and this is your basic status screen. It tells you what your Wi-Fi address is, what your LAN address is, what the WAN address. This one's not connected to a WAN, so that's why it's done. It tells you what your gateway to the internet is, and it tells you what your PC that you're looking at this thing, what your address is. So for instance, my laptop was given an address of 172.27.05. This is the signal noise ratio of the closest mesh node to you. And if you hit the auto, it updates it every couple seconds. This is your firmware version. And this one is version 042.
It's now old.
Which is now old. And I'll get to that later too. This is the time. It goes out to the internet, gets time, tells you how long this one's been up, and how much memory you've got. Yes, and actually, yes, you can get this information off of your router, and if you go to the status, if you click on this mesh status button right there, you get one where you can see your neighbors. So you can see everybody else. And if you click on them, like in this case, if I clicked on this guy, I would see that screen for that guy. And I could actually look at his mesh, look and see who he sees, and see what their statuses are from their perspective. So I can hop through a whole mesh network to see how each other mesh node can see everybody else and how they look. The other thing that Rusty will get into more later, in one of the later sessions, is that you can put services on your mesh router and advertise them to the rest of the world. So in this case, I'm on N7. N7 provides an IRC chat. So if so you can talk to people and say, let's go to the chat client or the chat service on 85 IBN7. I click on that and it'll pull up the chat window, and I can be chatting with somebody else that's somewhere else on the mesh. This one not only has an IRC chat, but it also has a small FTP server. So we can actually copy files across the network to each other using the memory that's in the router. No, we provide THCP also.
That big picture you have,
That's correct. Okay. When you first start up, you got to worry about your setup. This is the setup screen. And this is what you have to worry about. Right here is where you set the name. In this case, we use the standard where you use the call sign first, and then a dash, and then some kind of description. And in my case, this was just node 7, so I just put N7. Like the one I've got at St. Paul, I've got actually St. Paul, 85IB-St. Paul on that one. Rusty has one that's 85
AE-kitchen.
AE-kitchen, because that one's in his kitchen. And so you can pretty much name it whatever you want. It's going to want you to change the password. The default when you first log in is going to be HSMM for the password, and it's going to ask you to change that when you start working on this one. It'll automatically give you a IP10 address for your Wi-Fi, and it'll base it off your MAC address. Do not change the SSID. This is HSMM Mesh. This is what everybody's going to see, and this is how they know that they can talk to each other. So if you change that even by one letter, it's going to say that's a different network. I'm not going to, you're not talking to the HSMM Mesh network. Default the thing to channel 1. It defaults to channel 1. Stay on channel 1. We had some people that have their network on channel 2, and it causes all kinds of problems. Now, these are the ones that you can set. There's an RX antenna, a TX antenna, so you can have diversity, because for use both antennas, or you can just say right antenna or left antenna. Well, the first question is, well, which one's the right and which one's the left? Unfortunately, Linksys was not consistent between their revisions of the same model. So you have to try it. And that's the only best thing I can tell you, is try it, get a second one, take the antenna off, check, lower the power, check between the two, whichever one has the highest one, you say right, and he's higher than the left, and you know which one's the right one for your router. TX power maximum is 19 dBm, which if you're doing anything outside, that's what I'd recommend. If you're going to be in a room like this, and we've had training classes where we've had 10, 12 of them, you don't want that much power. You want, we tell people to drop down to 3 or 5 if you've got a whole bunch in the room, because it's just too much RF and things start crashing. For training. We have Digital Tuesdays in Lucas, and so we'll have people bring their routers. We'll show how to do things, and everybody will have their router on their desk so they can play with it and actually do it themselves, as opposed to just watching somebody say, do it this way. No, you do it, because you learn it better that way. And so we'll have, and when I have my webinars, we've had 15, 20 people, all with their own routers in the same room, doing what we're telling them. And then immediately they'll have the question, why do we have to do it this way or that? It's just for me, it's a better way to learn. Okay, the router has 2 antennas. And you've got basically 3 choices. You can have diversity, which says use both of them. You can have, you can set right or left. I've never had an excuse for using one on the right, on receive and one on transmit. It's theoretically you could do that, but usually if you're going with a big antenna, you've only got one of them hooked up, unless you have two big antennas. So that's why you'd set both of these to the right side or to the left side. If you have only one antenna, Yeah, but most of the Linksys antennas have two. So if it's only got one, it'll default to the one. But most of the routers that we're using have two antennas. If you want to, you can, but most of the time I wouldn't. I would if I have just one antenna, I'd set them both transmit and receive to that one antenna. Yes. That's usually when you use it, is when you've got the external antennas. With 2.4, you can, sometimes just this much difference can make a difference between making the break and the contact. And that's why they've got two little antennas on some of those routers. All right, this is the, if you go into the setup, what we looked at just a minute ago is basic setup. This is the port forwarding and DHCP services. This is where you can tell other people what you've got. So in this case, this one has, this one's the IRC one. We've loaded a patch in here that a service for IRC to make him an IRC server. Well, we have to tell it to open up port 6667 on this node, and then we advertise it. That's so you can see it out on the thing, and so it says IRC, my node, that port, and we're telling it this way. It's telling it /mesh. That means go to the mesh chat room. And that's what this will do. And some routers, or some servers, or not servers, Internet Explorers, actually Opera does it really well. If you click on that link, it'll actually put you in the chat server on the right page. Internet Explorer doesn't do that, but some of the web browsers will do that for you. The other thing is you can reserve DHCP addresses. So what it'll do is, for example, I've got, I can reserve this one IP address for my laptop. And so whenever it sees my laptop, it'll give me this address. It won't give it to somebody else. The other thing I've got is I've got my DMZ server set up as my laptop. So that way, if somebody comes in with this and they know about it, they can use my laptop and do file transfers and stuff like that to a place, to one of my share files on the laptop that I've opened up to let people share. So that gives me a lot more disk space for moving files. And then the last section in the setup is administration. This is really, really cool in version 4. What you can do is you can tell it to refresh. It'll go out to the internet. If any one node in your mesh network has an internet connection, it'll find that mesh thing. It'll go out there and it'll download any firmware, or it'll tell you what firmware upgrades there are. And then you can select which one you want, download, it will download it. You can do this from being plugged into the router, or you can do this across the net. So if I'm on my node 7 and my node 8 is up on top of somebody's water tower, if I can connect to it over the RF, I can upgrade its software without physically having to be there, which is really, really cool. And here's an example of selecting firmware. So I can, right now this one is 4.2. I can reload the 4.2. I can go back to 4.1 or 4.0. Sometimes what you'll get is you can also get a patch. So what's out there right now is there's a 4.3, and there'll be both a TRX file for it, which will reload the whole thing, or there'll be a patch that'll just upload what's new. And that's what I like to do because it doesn't change all my settings. The patch won't change all your settings. Okay, what are the routers? These are the routers that work at the moment. The WRT54Gs and the WRT54GLs. Now for 54G, it's only version 1 through 4. All of the GLs will work. And then these are some that you might find elsewhere that do work. But these are the ones you're going to see the most. These two right here. If you're doing anything and you want to buy new, stay with that one to be the safest. That's probably the only one you can buy new nowadays. But it's good to get the list. We have a list on the website, the HSMMMesh.org website. A lot of people put that list in their billfold, and when they go to a swap meet or someplace, they'll have their list and say, "Ooh, is that one of the little big ones?" And they'll get it. Okay, the one I like, the Linksys WRT54G used is what I like. You need to make sure you get a version lower than version 4 or lower. The new one, once they went to version 5, they shrunk the memory, and so now our software doesn't fit in it. The current version is version 8. It only, instead of 4 megabytes of flash, it only has 2. And the antennas are soldered. So you can't remove the antennas on the new ones. So that's, so don't do anything above version 4 or, on the WRT54Gs. Now the WRT54GLs are basically version 4s, but they have upgraded them a couple times with faster processors. But they still have stayed with a 4 megabyte flash. And I've seen them from 54 to 79 for brand new. But there's lots and lots and lots of them out there in the used market. I picked up one for $15 today, and I just didn't want to spend $20 to go get some more. So that's one of your options. The other thing that's nice about this is it has a built-in regulator for 12 volts. When I first started, I was using a different program other than Mesh, but I went with a Buffalo router because it was cheaper than a Linksys router, and it would do DDWRT, but what I found out was it expected 3.3 volts in. So now all my ham stuff doesn't work. But this one, it runs off 12 volts. It'll actually run from 7.5 to 18 volts. I haven't tried higher than 18, but it works in those ranges. It has 2 serial ports if you want to, if you're in a hacking mood. This is, after you've defaulted, or after you've loaded the software, this is the default information. First off, here's where your 12 volt power goes in. Center's positive, outside's negative. Use the WAN port to go up to the internet. So don't expect to plug your PC into this one and get anything to happen. This is the reset button. You can use that to, I think you have to hold it for 10 or so seconds, and it'll put it back to default mode. 30 seconds? Okay. And then this is the one that you can plug your PCs or your switches into. And what it does is it gives you an address in the 172.27.0.1 space. So it's basically 172.27.0.2, well, actually it gives you numbers from 5 to, I think, 25? Yeah. This is the default. You can change those in the setup. Yes, this is giving you, this has a DHCP server in the router that will give you those instructions when you plug in. That is correct. We are going to this because the mesh, or we have problems if you try to route a 192 through a router to a 192. So you need to have a different subnet on the WAN side and the LAN side. So normally on the WAN side you've got a 192, 168, either 0 or 1 or 2. One of those three is usually what you have at home on the WAN side. So what they've done is they said, let's go completely away from that, go to one of the B-class nets. We've actually set up for C, but it's in the B-class area, 172.27. And that way it'll route through your home's system to the internet. And that's why they changed that. So it won't conflict with your home network. The big thing everybody likes to talk about is antennas. Well, the ones that you can find in the retail stores are expensive. Even Fry's was unbelievably expensive. Then you need to decide whether you want vertical or polarity. Vertical is really preferred for mesh because you don't know where the next mesh node around you is. Unfortunately, it's also what laptop computers use. I like horizontal for the long distance point to point. Because all of a sudden now, all these PCs that are vertical, you've got them attenuated because you're horizontal. And so it helps you out when you're doing your long distance stuff. Now the range is based on antenna and noise. And we found that out really seriously last year at HamComm. Thursday night, we were having no problems. And Friday, when all the people got here, and everybody now has a cell phone that has Wi-Fi on it, that noise level just started going up. And we could talk from the hallway to the inside vendor area on Friday or Saturday. We had no problems on Thursday, but just because of all that noise and bounce and RF, we couldn't do anything. So, assuming we got a clear line of sight on a good day, and both sides are transmitting at 19 dBm, as a general rule, with two 12 dBs, you can get 5 miles, 15s, you can get 10 miles, and two if they're 19 to 24, or 19s, you can probably get about 24 miles. Problem is that trying to find line of sight that'll get you 24 miles is kind of hard. It's easier here in Texas because everything's flat, but if you're in a hilly area, that's going to be trouble. 19 dB in watts is 78 milliwatts. That's not a lot of power, but they have amplifiers. You don't use them. We don't need them. And of course, bigger antennas is better. Here's one I like. People say, what should I buy? What should I buy? Titan Wireless. They're in Round Rock, Texas. They've got the lowest price 15 dB Omni that I've been able to find. It's $60. It's got an end connector. So now you're going to have to find an adapter from reverse polarity TNC, which is on the back of the Linksys routers, to an end connector. HamComm has it. Nobody here, as far as I can tell, has them. I checked. Yes?
Johnny down at Austin Amateur Radio Club stocks them now. I told him to get them, and every time I go down there, he's got them there now.
Okay, there's one in Austin. Once in a while, I'll see something at Fry's, but Fry's is not general. HamComm sells them for $5 for just the adapter. There's some people that sell the cables with a reverse polarity TNC on one side and on the other, and so you can get a little 3-foot cable, and those are nice for some of the things. All right, Another neat one is this little Titan wireless, it's about a foot tall. It's an 8 dBm. It's only $29. This is good for special events and short distances. Some people put these on their cars because it's only a foot tall. It's shorter than your 2-meter antenna. And that way they have mobile Wi-Fi or mobile mesh. Now my favorite antenna is what's called a root antenna. It mounts on the mast. It's easy to switch from vertical to horizontal. And what it is it's an antenna and a case. So you can actually put the router in here. And so one of the problems with 2.4 gigahertz is that it attenuates in coax, big time. Long, you can't even talk about more than 3 feet of coax, or you don't have any signal left. And so what this allows you is really, really short lengths of coax, because you're actually in the same box as the antenna. So your coax is really this long. Then they have 2 of them. One's a 19 dB. It's about this big. It's a pretty good size one. I've seen those around for about $70, $74. The 15 dB is 36 to 45. Pacific Wireless is one of the main sellers for that, and they usually have the best prices. This is what the inside of them is. Now they've got, I haven't figured out yet, but they've got different people sell them, and some of them have more thickness than the other for the case part. If you've got one of the narrower ones, then you have to take your board out of your box. If you've got one of the thicker ones, you can leave the router inside. So just leave it off there. There's a metal plate here, so you need to insulate yourself from the metal plate or stand off from the metal plate. And right there's where your antenna connection is. So you have to have a jumper from this thing to your antenna. And like I say, you have to figure out which is right and which is left, so that you put this here. Usually I'll put something on here just so that I don't have so I basically have a dummy load for this side of it, the one that I'm not using. So we come in with our Ethernet, and we come in here and we have what we call a power over Ethernet injector, and I'll get into more about that. But basically we're using 2 of the wires that are not used in the Ethernet cable to provide power. So that way we only have to run 1 wire up to the box, and that's the Ethernet cable. It simplifies our wiring. But this splits it, so we split it out, and the power comes here, and I use power poles here, and then plug into the router with the power. The other side, it splits the Ethernet, and it winds around through here and plugs in to the LAN or the WAN. If you're going to talk to your PC, then you want it on the LAN side. If you're going to hook this up to the internet, then you want the WAN side. Some people put a second Ethernet out here, one going to WAN, one going to LAN. That way they can decide later without opening the box. Okay, that's WRT54 out of the box. Ethernet cables. That's a weatherproof Ethernet cable, so it doesn't let water in the box. Antenna connector, power poles. Okay, the other one I like is the Hyperlink sells these die-cast reflector grids. They're like grills, barbecue grills. They sell a number of different ones. The thing is if you start looking at these prices, if you're going to do a 19 or a 15, you might as well get the Rutena, because with this one you have to have a box. And a lot of times we use a sprinkler box, but that costs more too, so you might as well get the one with the antenna with a housing built in, so you don't have to have an external box. So the only one of this that I use is the 24 dB. Because the 30 dB, I can't believe they jumped the price that much. But it's not. For 6 dB, it's not worth it. I can put a couple of nodes out there in between for that price. I'm sorry? It's the gain gain of the, 24 dB is the gain of the.
You said the 19 was 76 milliwatts?
No. 76 milliwatts is the transmitter. Then this is the antenna gain. This is antenna gain. So like I said, 24 dB is recommended. Otherwise, you know, I use Route 10 because it's cheaper. I'm cheap. Here's some examples. KP5 MFW. He has two antennas. Basically, he's got a 24 dB, and this is set up in horizontal polarity. So what he's doing is he's trying to reach a long ways out to connect to a mesh network that's a long ways away. And then he's providing mesh service omnidirectional, horizontal, or vertical polarity for his area. And so that's how he does. And again, this is like a sprinkler box that you can get at Home Depot or wherever, and that's where the router is. Yes?
With his setup, with the omnidirectional one,
Yes.
does he have those two antennas connected to one router?
Yes, he's got to the right side and to the left side.
Okay.
And the diversity part of the antenna, or the diversity part that's built into the router automatically detects where the signal is and switches for you.
So you just leave it at diversity?
Yeah, you just leave it on diversity in that case. I didn't believe it would work either, but it does. When I first saw it. 8500, I thought he was here, or he's supposed to be here. This is his setup. He just has a box and a 12 dB Omni, a tripod and mast, 5-foot mast. And, you know, that's his kind of go kit for this. And there's probably, he doesn't have power on this one, but that's, that's just one way to do it for a portable system that'll get up and running. This is the one that I tried to put up on our repeater site at, just up the, actually you can see the water tower that way if you look out the window. This is my box. This is the 15 dB Omni. And then we have some coax going down here for lightning, the lightning arrestor. Unfortunately, unbeknownst to us when we installed this, the city installed 2.4 gigahertz narrowband transmitters to control their traffic lights. And their power saturated our receivers and couldn't communicate. We tried moving off frequencies to, from channel. Turns out they were using channel 1, channel 6, and channel 11 for their stuff. And so we tried in between. Rusty and I were out one day trying all different combinations. Trying to go in between them with channel 3 and didn't work. So we had to abandon this approach. I'm trying to get on another water tower in Lucas. And so that's. But this will give you an idea of what I had up in there. First, I had a version 2 router. I used a stock antenna for my dummy load. And then this is the one that went up to that 15 dB Omni. This I picked up from Titan Wireless. It is basically a power over Ethernet injector and a surge arrestor for the Ethernet, which I thought was kind of cool. And then that has a ground wire that went to the water tower because the water tower is a pretty good ground. And then the other thing that, this is the antenna cable to the antenna. The other thing I found, and I'll get into this in a little bit, is when you've got a really long Ethernet cable for your thing, you need a capacitor. And it needs to be 10,000 microfarads or bigger. Pardon? If I've got the capacitor on there, I can do 300 feet. If I don't have the capacitor on there, 100 feet starts getting iffy. Okay, these are the companies to know about. Fabcorp, HamComm, WLAN Parts, and Titan Wireless. Those are some of the cheapest cheapest prices on the internet. Now, if you're going to do a permanent, you need a surge protector. Make sure you get the ones that go over 2.4 gigahertz. There's some that are good for HF, there's some that are good for VHF, some good for UHF, but there's some that go all the way to 3 gig. You want the ones that go to 3 gigahertz. And make sure you have a good ground. Again, you need to protect your Ethernet also for a permanent installation. And there's bunches of out there. Titan Wireless has a number of different ones. For your Ethernet cables, I put them at the top and the bottom. And again, make sure you've got a good ground. Now, passive power over Ethernet. I promised to tell you a little bit about that. There's simple adapters. You can make them or purchase them. There's a place on eBay. I think it's eBay you can get them. It costs $1.95 for both ends, and $6 shipping from home. And so you say, oh, well, I'll buy 3 of them and save on shipping. No, they said you one at a time, 3 packages. So, oh well. I like to use the power poles for 12 volts because that makes it compatible with all the rest of my hand equipment. So basically, if you're doing this on your own, pins 4 and 5 of your Ethernet thing, we use 12 volts, the plus 12. Pins 7 and 8 is the 0 volts to the ground side. And that's basically all the power over Ethernet injectors do. Main thing is it simplifies your wiring. Now all you have to do is run one cable up to your antenna and router. You don't have to have one for power, one for data. Here's one that a friend of mine, John Fields, made. We have a place not very far from here called Altex. They sell all kinds of telephone stuff and Ethernet stuff. And so he used a white one for without power. And once you've injected power in this box, he had that on the red side. So, and then he got one of these little things that had power poles, and so he also has a power pole splitter here. So he can hook up 4 devices for power poles and up to 6 antennas. This is overkill, but hey, he built it, and this was before we could find the $1.98 ones from China. Altex. And I keep one of these in my battery box, just in case. All right, the 12-volt power over Ethernet. We had problems when power fluctuations on when we had runs of 200 feet and over. To smooth out the current demands, what would happen is this thing transmits and doesn't transmit. Transmits and doesn't transmit. Back and forth all the time. Well, what happens is when you want more power, or when it transmits, it needs more power. So it tries to suck that off that really, really long inductor with the Ethernet cable, and the voltage sags. But it's got a switching power supply in it, so it says, okay, I can just suck more power, more current, and keep my power where I want it. Well, that causes it to drop even more. Well, pretty soon, it catches up. But then by then you're turning it off, and the power goes boing, way up high. And it was bouncing all over. I would see from 5 volts to almost 20 volts. The power at the other end, watching it on an oscilloscope. So to do it, we needed a big capacitor. I said to my friends, okay, how big a capacitor do I need? Oh, a couple hundred microfarads. No. I bought 3. I bought 100, 1,000, and a 10,000. So I said, let's try the middle one. It didn't work. Turns out you need more than 10,000. 10,000 or more to make it work. Actually, the voltage was steady enough that I was able to reduce the supply at the over this long cable, so that at the router, the supply was 7.5 volts, and it worked. So it knocked out that fluctuation. The other thing is with these Linksys routers, if you're playing with them long enough, you're going to find this out. If the voltage drops below 7.5 volts, it goes in this weird mode where it just sucks 1 amp. It doesn't work, it just sucks 1 amp. It will not come out of that mode if you raise the power. You have to break power and give it power again, and it'll come out of that mode. So that's the other reason I use these. I've just started putting them in all of my boxes, so I don't have to worry about. Now, does this one have the Does this one have the switch or the capacitor or not? Yes. It'll go. Yeah, it'll work all the way down to 7.5.
So if you didn't have all that loss, if you only had 50 run, you wouldn't have that.
That's correct. And you won't have as much fluctuation in a shorter run either. I just put it in just because I do a lot of public service events. I may want to grab this one now. It's in that box. Now, does it have this capacitor or not? I just put them in. They're only $2 for a capacitor. So I just put them in on all of them. And now I don't have to worry, does this one have it or not have it? So that's the reason I do it. Because, well, that's what I'm saying. Because I don't know how long my runs are going to be when I'm deploying. So I just put them in on everything. All right, some interesting websites. The Mesh site. This is where you get all your information. Presentations like this are on there. We have videotapes on there. We have lots and lots of stuff on the Mesh website. This is where you get the software for it, and hopefully you can answer all your questions. Another good place is Building a Rural Wireless Mesh Network. This is a free, you can get it, just download it. I saw Rusty had actually the book that he got for like $20. So it's also available in a book, but you can buy it, you can just download it for free. Wireless network, wait, was it that one or the wireless networking?
The one that just popped up, though.
This one. This is the one that you get for,
Yeah.
yeah, you can get this one for free, or you can buy it for $20.
Well, that was with shipping like FedEx ground. It was less than that. It comes from like Oregon.
Okay.
But, you know, for less than $20, you had it hand delivered dead tree.
Yeah. Another good thing is John Beadle's page. It's kind of dated, but it gives you a lot of good information for HSMM. So, where to go next? HSMMMesh.org. That's the main place. We have meetings here in Lucas twice a month, first and third Tuesday. We call them Digital Tuesdays. Check the K5 Park calendar for the exact location. Austin has a Digital Wednesday, which I think is the fourth Wednesday. Yeah, fourth Wednesday of every month. We have 2 email lists locally. The Dallas Area Working Group, which is the DAWG-HSMM Yahoo group, and the Austin HSMM Development, that's down in Austin. You should, between those 2 groups, you can get any question answered. Now, the interesting thing is, today we have a new version of the software, version 4.3. So all of my routers don't have it yet because it was this morning.
Yeah, your
Yeah.
tunnel has it.
Oh, my tunnel has it.
I did it for you.
Thank you. We had some problems. One of the problems we had was that to find out if we were on the internet, we would go out, we'd ping this internet address, it would come back and say, and then we would know, yes, you've got internet connection. They stopped responding to pings. So we had to change our addresses as to where we go. And that's the main thing with that. So basically, the internet changed, so we had to modify our stuff to adapt to it. And then other seminars at HamComm. At 2 o'clock, Glenn Curry is going to be talking about the HSMM Mesh update for 2012. I'm sort of doing more of a beginner class. And then at 3 o'clock, Rusty is going to be doing applications and accessories for HSMM Mesh. So this is once you got it, what to do with it. You know, I'm more talking about, let's make connections, and now he's saying, okay, let's go find useful applications. I don't have my, let's see. Oh, I'm 1 minute over. Well, I guess we'll have to wait for questions at the 2 o'clock one. So thank you very much for coming.